Blows my mind how bad I was at counting. It goes from 87 to 89 now. Um, 89 says, oh, hey, also on 86, you didn't have the option for does not exist originally. That was a typo. Maybe yours says it, maybe it doesn't, but it should have said it. So there you go. My bad. 89, if f of x equals negative 3 ln of x squared, where does f prime of x equal 12? Well, you do not know how to take the derivative of the natural log, so you are stuck graphing this. So enter negative 3 ln of x squared into y1. So put negative 3 ln of x squared into y1, and we want to know where does f prime of x equal 12. That means we want to know what x value does the derivative have a y value of 12. So go then to y2, hit math 8 to get your derivative up, and now what you should do instead of retyping everything, all you need to do is hit, if you're on an old calculator, hit the vars button to get your variables. So it's to the left of the clear button. Vars over to yvars, function, hit enter. Y1, hit enter. Then do a comma, and then do x, and then do another comma, and another x. That will graph the derivative of y1. Now, equivalently, you could have just entered into y1 and derive, type the function, comma, x, comma, x. So I guess that probably would have been faster, but whatever. Now then, into y3, type 12, because you want to calculate the intersection point. So I'm actually going to go up and turn my y1 graph off, so I'm going to hit enter. So yeah, now that I'm saying this, it probably would have been better just in y1. Let's get rid of this stuff right here. You don't need to look at that. In y1, you should probably just graph and derive, type your function, which was negative 3 ln of x squared. Close it if you want, doesn't matter in this case, comma, x, and then in y2, go and type 12. Or if you're on a new calculator, y1 equals, hit alpha window 3 to get d over d, type in an x there of, type in your function, negative 3 natural log of x squared, go out, and then your x is filled in there, and then it has to equal x. You want it to equal x. That's kind of hard to see, sorry. You want it to equal x right there, because that will graph the derivative at every x value for you. And you still want y2 to equal 12. So now I would just do a zoom 6, because I don't know what this thing looks like, but I do know it's some type of a natural log function. No, I don't actually, because it's derivative, and I don't know what the derivative looks like. But do a zoom 6 just because you don't know what to look for, and hopefully something will happen. But actually, a zoom 6 sucks because zoom 6 gives you a 10 by 10 window, and we know our y value is 12. So go to your window, make your y max, like, I don't know, 15, so that we can see that value of 12. And now we'll graph it again, and we should be able to see the intersection point this time. Takes a while to graph because it is literally calculating the derivative at every single x value to the best of its ability, but it does graph it, and now we can hit second trace to get to the calculate screen, and we want to choose option 5 for intersect, and we want to choose the first curve is the derivative. Now it puts you at an x value of 0. That looks like it has an asymptote at 0, so to help your calculator, move to the left a little bit, hit enter. Second curve, hit enter. Guess, hit enter, because it only intersects once, and it will tell you x equals negative 0.5 with a bunch of zeros after it, and then maybe it shows you a 7. Maybe it tells you exactly negative 0.5, but that should be our answer, negative 1/2. The original answer key said positive 1/2 there. It should be negative. My bad, yo.